Welcome to Kaleido, the blockchain business cloud. Let's take a quick walkthrough of the platform and go through the process for creating a consortium and spinning up a private blockchain environment. Now, if you're a new user to the platform, you need to register your business organization with Kaleido, and you do this by creating an account. This is a very straightforward process. Simply choose the geography where you'd like your details to be hosted, supply an email, choose a strong password, confirm your password, and then choose a name for your organization. This is how you'll be represented on the platform. For example, Org. Confirm that you're not a robot and click Next. You will receive a verification code to the supplied email. Take that verification code, input it to the console, and verify your account. Once you're verified, you can log into the platform. I've already created an account, so let's log in. The first prompt upon logging in is to create a consortium. And a consortium is simply a high-level grouping of the members that are going to participate in your blockchain network. On the Kaleido platform, a consortium is encapsulated by what we call a charter. And a charter has two parts. It has a mission, and it has an ownership model and a listing of the members. So first we need to name the consortium. We'll call it Demo. And demo time for the description. You can select a geography where you want the consortium to be hosted, and this geography will propagate to all of the environments that are created against this consortium. We'll leave it as the USA default. Now we can choose our operator model and list our members. The two choices are single proxy organization and multi-organization. Single proxy is perfect for POC orchestrations. This means that your Kaleido organization will be serving as the gateway to the network. You're going to own and operate and control all of the resources in the network, granting access to fellow participants. And these resources include the nodes and the authorization credentials. The other option is multi-organization, where each Kaleido organization individually owns and controls their own resources. We'll opt for single proxy for this demo. So let's create a few simulated member participants, Org B and Org C. And let's complete our charter. So the charter's done and the consortium is done. And this is really just a high-level framework containing our name, the description, and a listing of the memberships. What we really need is an isolated domain, a unique namespace to host the node runtimes and provision the security credentials. And we do that by creating an environment. All right, similar to the consortium, we provide a name, and now we can choose the flavor for the environment, the blockchain protocol. So there's two choices on Kaleido. The first is Geth, which is the hardened Go implementation of the Ethereum node. Very stable. Many people are very familiar with it. We offer one consensus algorithm with Geth, proof of authority. The other option is Quorum, which is a fork of Geth, and it has a constellation module that accommodates private transactions. And Quorum offers two consensus algorithms, IBFT, which is a Byzantine fault-tolerant implementation, and Raft, which uses a leader and is very high speed. So we'll choose Quorum and Raft for this demo. And the last piece is to optionally configure a mainnet relay. The mainnet relay is a very powerful mechanism to counter against collusion. It takes aggregated snapshots of the blocks all containing transactions, takes a root hash of that, and propagates it up to the mainnet. As a result, no one can go back in time to retroactively try to manipulate blocks and change block contents or the state database. There's a record that indelibly exists on the Ethereum mainnet proving the state and the block contents at that point in time. So we will choose this feature. Now we can finish. And again, similar to the consortium, the environment is just an empty namespace until we actually provision the node runtimes that can host the ledger and accept external connections. So let's provision some nodes. We have our two membership identities in the consortium and subsequently in this environment, Org C and Org B. So let's create a node for Org C, call it Org C node. And then let's add another node for Org B. And we'll call it Org B node. And now we see a prompt here saying that there's no application credentials associated with this node. And we saw the same prompt when we created the first node. And this is saying that we need to generate some security credentials in order to externally connect to the node in this environment. So we'll create those now. We need to create them against one of the memberships. We'll choose org-c, so we'll call them org-c app credentials. Next. And this is a username password combination for basic access authentication. And this password is the most important piece. This is ephemeral, and this is not stored by the Kaleido backend. And this is the secret associated with this username. So you need to copy this and store this somewhere safe. And this is what a Web3 application will need to send to the network in order to authenticate itself. So we will copy that, store it somewhere safe, and take a look at our environment. So we see that we have the two nodes that we just created. They've started up, and we have a system monitor node, and then we have our app credentials here. The system monitor node is what allows for this block explorer feature to work. It's propagating all of the blocks and transaction information into a chain analytics feature that we have. So what we will do is we will use those security credentials from org-c to connect to the network, deploy a smart contract, and then take a look at the block explorer to see these transactions. So before kicking off our transaction, let's take a quick look at the block explorer. And we see that we only have a Genesis block. Now, wrapped consensus, which is our chosen implementation for this environment, only cuts blocks when transactions come into the network. Alternate implementations such as IBFT or proof of authority will actually cut blocks on configured intervals. So if you have very low transaction throughput, you may see a large allotment of blocks that are devoid of transactions. Okay, so let's go back to our environment. Now, what I've done in my terminal is I've taken the org-c application credentials and bundled them with the org-c RPC endpoint to create a fully qualified string that we can target this node with. So let's take a look in the terminal, and what we're going to do is we're going to call a simple test program that's going to deploy the simple storage smart contract. And we can see that I've set the URL here with the username and secret, and we're targeting the RPC endpoint of the node, and we're calling a deploy function. So this program will find an account in the targeted node. It found the Ethereum account, and then it's going to compile the simple storage smart contract and deploy the bytecode, and then provide us with an address to call. So we will very quickly call this address just to prove that we can interact with it, and then we will take a look at the block explorer. So we'll pass in the address, and then we'll call a set function to change the value of our parameter. Okay, so we've deployed two transactions to the network. So if we go back to the block explorer, we should see a deployment of the smart contract and an invocation of that address. And we do. We see the creation of the contract here, and then we see a transaction that called that address. Okay, so the last powerful feature of the block explorer is the ability to verify source code. And this means that you can locally prove that the deployed Ethereum bytecode matches the local Solidity code. So you know that the contract you're calling is precisely what you think it is. And this is a very powerful affirmation feature. So here we see the bytecode, and what we want to do is we want to compile the source code and make sure that these two things match. So we will upload the source code. We'll input the contract name, and it wants the name of the contract that we passed to the compiler. It wants the version that was used in the Solidity code, which was 417 in our case. And then it wants the actual contract source code. So we'll go back to our terminal, and we will grab the contract source code, input it into that field, and see if it verifies. And if it verifies, then we can call this contract with confidence. And it turns out that the deployed bytecode actually matches the local code. Not a surprise in our case. But this is extremely powerful if a counterparty actually deployed the smart contract and you on your end wanted to make sure that it is exactly what you thought it was. Okay, so now we can exit the Explorer and we can go back to our environment. A few of the final features of the Kaleido platform, we have an API key which will allow you to administratively exercise all of the calls that we just did, the resource creation, deletion, etc., via the command line. We expose the full REST APIs, allowing you to sort of script and create your own lifecycle management. And then finally, there's a settings option here where you have the ability to invite members, co-administrators to your organization who can share in the ownership and operational tasks. Okay, I hope that was a very helpful walkthrough of Kaleido, and enjoy the product.